Hello everybody, this is Chris Novel. Today I'm going to show you how to use the TI-84 calculator for doing a linear regression. And so when you open up, I got the emulator here for us to look at. What we want to do is we want to enter our domain and range in, which will be our list 1 and list 2. And then what we'll do is we'll have the calculator perform a linear regression equation on that list of data. And we'll use that to make some inference about some stuff. So first thing we're going to start off with is going to our stat editor to go to the list where we can put everything in. So under stat, okay, go to stat, you're going to choose number 1, edit. And this is where we can enter in our domain in list 1 and range in list 2. Okay, so let's say that this is some company maybe, and maybe the company in January, say, let's make that month 1, right? And February, let's say these are their months. So March, right, April, May, and June. Okay, and let's just say then also that each month they have a certain revenue and cost, and revenue minus cost is profit. So let's say list 2 is going to consist of their profits. So maybe this store in month 1 in January they did maybe they made $5,000 in profit. In month 2 they made $5,400 in profit. In month 3, they made $5,500 in profit. In month 4, they made $6,000. So making up some numbers here, and let's say then we're at $6,200, and then so forth. Maybe in June they made I don't know, $7,000 or something. Okay. All right. So basically, we got the months corresponding from January through June, and then we also have the profits associated with each month. So what I would like to first do is look at this data as a scatter plot to see if there's some sort of trend that I could use to find an equation that I could use to mimic or go through the data so that I could use it to approximate stuff. Okay. So what I mean by that? Well, let's take a look at the data here. If I go back to a table set, I'm going to see what this stuff looks like. I'm going to turn plot 1 on. I'm selecting plot 1 and selecting on, and making sure that list 1 and list 2 are going to be what I'm going to be plotting. Now, you can store your lists in anything you want, but when you plot them, make sure that your X and Y lists are corresponding to your domain and range. Okay, so I select on. Right now, it's going to choose color blue, and it's going to make my marks look like kind of these little mini squares. And I better make sure that I can see this, right? So I got to go to my window and set it up. So I had the months going from 1 to 6. So maybe I'll start the X minimum at 0 and go as far as, say, 8 or 7 or something like that. And then I had the scales by one month at a time. Now I think the Y minimum was like $5,000 for the profit, right? And then the Y maximum was around 7, I forget that. But let's say the Y minimum was, let's just start at 0, and let's just go as far as 8,000. Okay? This way we can see all those values when we plot them in the scatter plot. Our Y scale should be set from 0 to 8,000. How about we go by either 500 or 1,000 for the increments? I'm going to go by 500. And once I'm at this point, I'm just going to hit graph and take a look at my data. Okay. And as you can see, it looks like it's pretty straight, right? I mean, you can almost fit a line through there. And, you know, it's not arcing like a parabola or anything like that. So what I might want to try to do is find a line that best fits through all that data. Okay. And in statistics, they came up with an idea called the least squares, or the linear regression equation. And what it does is it takes the square of all the distances between these points in the line we're trying to find, and it minimizes their sum. Okay, so you can learn more about that in stats, and more calculus, you'll be able to prove that. But for now, let's just say that I want to use the calculator to find the best line that's going to fit through the data points. So to do that, what we're going to do is we're going to quit out of here. Okay, I got the plot there. I'm going to go to statistics again. And this is where most of our work is going to be done. And remember, we already edited list 1 and list 2. We don't need to redo that. But this time what we want the calculator to do is calculate. So go to calculate on the right. It's in the arrows. And you're going to scroll down until you get to this here that says lin regression A plus BX. You can also use number 4, lin regression AX plus B. The only difference is the slope value in this one will be A versus the slope value in this one will be B. It'll be writing it in the reverse order, but you'll see from either window, it'll give you the same linear equation. So don't choose ln. If your data looks like a natural log function, you might want to use that, but our data is a linear regression, right? So based on the shape, we pick which model we want to use. So I'm going to just pick 8. And right now, list 1 and list 2 are the X and Y lists. So that's what we want. So we want to calculate that. So we just hit enter, 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 enter. And there's our regression equation. Okay, now what I'd like to do also is be able to graph this inside the same window that we were looking at those points in. So to do that, what we're going to do is we're going to go to the Y editor. Okay, and I got some old stuff in here. Let me delete this old stuff out of here. Okay, and in the Y editor where you graph, we want to store that equation that we just found, right? So to do that, I'm going to do it this way. I'm going to go to, I believe it's math. No, it is, sorry about that. It is not under math. It is under VARs. So go to VARs, and then under VARs, choose number 5 for statistics. Go over to EQ by using your arrows to the right, and select number 1, regression equation. Okay, so there's the regression equation, but what happened was it stored it on the home screen. What we want it to be stored at is in the Y equals editor, right? So we want to store it there. So when we start this out, make sure you're there. Go back, we'll run through it again. We're going to go to VARs. We're going to go to statistics, number 5. Then we're going to choose equation, and it should store the regression equation now in where we would graph it. This way we don't have to round stuff, and a lot of times people just round these decimals off and don't get as accurate as a result because of it. So let's hit graph now, and we can see the line that's best fitting through those points is now that equation there. Okay. Next, let's say we wanted to approximate based on a trend that we see. We'd assume that the profits are slowly going up by looking at this. Not to say that in reality they can drop, but let's just say we follow this trend line. What would we expect their profits to be, say, in October, right? Well, October would be like month 10. So if I substitute the value for 10 into the line equation, I should be able to get out their profits now. Okay, so let's see. If I want to do that, I can exit out of here. We can either go to the table and choose values and just see what they would be. Well, here at month 10, October, we would expect the profits to be 8245.7. Okay. Now, these are the approximated values for the actual values, okay? The actual values I typed in list 1 and list 2, these values here approximate that. Because we were working with month 10, which is a number that's outside of the domain that I entered, right? If you recall, I only entered months 1 through 6. Anything that we're trying to predict outside of that data, we're going to call that extrapolating. Okay, when we're trying to estimate the value of something using this equation outside the domain, we call it extrapolating. If I wanted to know maybe at month 5 maybe halfway through 5.5 months, what my profit would be then, I could type in a value for X and see what it is there. That would be interpolation. So when we're testing values inside of our data, we call that interpolation. And when we're testing values outside of our data, whether they're domain or range, we would call that extrapolation.